The National Electrical Code, or NEC, addresses communication systems in Article 800. Specifically, relevant sections include 800.11, which covers general requirements, 800.44, focusing on antennas and their supports, 800.50, which deals with outdoor antenna installations, and 800.51, outlining grounding requirements particularly for the antenna mast and shield. With respect to contractor certifications and licenses, the installation contractor should have Federal Communications Commission, or FCC, certification. This FCC certification should be for the specific type of antenna and transmitter being installed to ensure compliance with the regulations governing radio frequency devices. In addition to FCC certification, a state or local electrician's license is generally required. Most states mandate that a licensed electrician perform electrical work, and this can include the installation of antennas and coaxial cables because these installations often involve grounding and bonding considerations that fall under electrical codes. Other standards and regulations may also apply, including FCC Part 15, which covers unintentional radiators and is relevant for low-power devices. IEEE 802.11 standards concerning Wi-Fi networks might be applicable if the antenna installation is part of a wireless network setup. Local ordinances or building codes can impose additional requirements or restrictions on antenna installations. These local rules can vary significantly and might cover aspects such as height restrictions, aesthetic considerations, or specific grounding requirement. Clearances, grounding, and bonding requirements are crucial for safe and effective antenna installations. Regarding clearances, the antenna mast should be installed a minimum of 10 feet from any power lines or electrical equipment. This clearance is essential to prevent accidental contact with energized conductors, which could result in electric shock or other hazards. Grounding is a critical safety measure. The antenna mast should be properly grounded using approved grounding methods. Acceptable methods include driving a ground rod or connecting the antenna mast to the building's electrical ground system. Proper grounding provides a path for stray currents and helps to protect against lightning strikes. Bonding is another essential aspect of antenna installation. The coaxial cable shield should be bonded to the grounding system at the point where the cable enters the building, and also at the antenna mast. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of electrical shock and minimizing interference. Depending on the specific installation, additional bonding or electrical isolation measures may be necessary to ensure proper operation and safety. This could include using surge protectors or isolating transformers to prevent voltage surges from damaging equipment. It's important to consult with a qualified electrician or electrical engineer to determine the specific bonding and isolation requirements for the installation. The NEC provides detailed guidelines for grounding and bonding communication systems. These guidelines help to ensure that installations are safe and effective. The NEC specifies that grounding conductors must be sized appropriately for the equipment they serve, and the grounding electrodes must meet certain requirements to ensure a low impedance path to ground. The NEC also addresses bonding requirements for metal raceways, enclosures, and other metallic parts of communication systems. These bonding requirements help to minimize voltage differences between different parts of the system, reducing the risk of electrical shock. The FCC also has regulations regarding antenna installations. These regulations cover aspects such as antenna height, location, and interference with other communication systems. It's important to be aware of these FCC regulations and to ensure that the antenna installation complies with them. Local building codes may also have requirements for antenna installations. These requirements can vary depending on the location, but they often address aspects such as structural integrity, wind loading, and aesthetic considerations. It's important to check with the local building department to determine the specific requirements for antenna installations in the area. In addition to the NEC, FCC regulations, and local building codes, there may be other standards or guidelines that are relevant to antenna installations. These standards or guidelines may be published by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, or the Telecommunications Industry Association, or TIA. It's important to be aware of these standards or guidelines and to follow them when installing antennas. Proper antenna installation is essential for ensuring safe and reliable communication systems. By following the NEC, FCC regulations, local building codes, and other relevant standards or guidelines, you can help to ensure that your antenna installation is safe, effective, and compliant with all applicable requirements. The grounding conductor should be copper or another corrosion-resistant conductive material. The size of the grounding conductor is determined by the size of the service entrance conductor, as specified in NEC Table 250.66. The grounding electrode should be a ground rod, ground plate, or other approved grounding electrode. The grounding electrode should be located as close as possible to the service entrance and should be accessible for inspection and testing. The bonding conductor should be copper or another corrosion-resistant conductive material. The size of the bonding conductor is determined by the size of the equipment grounding conductor, as specified in NEC Table 250.122. The bonding conductor should be connected to all metal raceways, enclosures, and other metallic parts of the communication system. The bonding conductor should be connected to the grounding electrode conductor at the service entrance. Surge protection is an important consideration for communication systems. Surge protection devices, or SPDs, should be installed to protect sensitive electronic equipment from voltage surges caused by lightning or other events. SPD should be installed at the service entrance and at any other points where communication cables enter the building. SPD should be properly grounded to ensure that they can effectively divert surge currents to ground. Proper labeling is essential for communication systems. All communication cables, equipment, and enclosures should be clearly labeled to identify their function and purpose. Labeling helps to prevent accidental damage or misconnection of communication cables. Labeling also helps to facilitate troubleshooting and maintenance of communication systems. Regular inspection and maintenance are essential for communication systems. Communication cables, equipment, and enclosures should be inspected regularly for signs of damage or deterioration. Any damaged or deteriorated components should be repaired or replaced promptly. Regular maintenance helps to ensure that communication systems continue to operate safely and reliably. The NEC provides specific requirements for the installation of communication cables in various locations, such as underground, in concealed spaces, and in hazardous locations. These requirements are designed to protect communication cables from damage and to prevent electrical hazards. The NEC also provides requirements for the separation of communication cables from power cables. This separation is intended to prevent interference between communication signals and power signals. The NEC also addresses the use of fire-resistant cables in communication systems. Fire-resistant cables are designed to continue functioning during a fire, which can be critical for emergency communication systems. The NEC requires the use of fire-resistant cables in certain applications, such as in high-rise buildings and in areas with a high risk of fire. The NEC provides guidelines for the installation of communication equipment in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. Communication equipment installed in hazardous locations must be designed and installed to prevent ignition of these flammable substances. The NEC also addresses the use of intrinsically safe communication equipment in hazardous locations. Intrinsically safe equipment is designed to operate safely in hazardous locations without the need for special enclosures or other protective measures. The NEC provides specific requirements for the grounding and bonding of intrinsically safe communication equipment. The FCC regulates the use of radio frequency, or RF, devices, including antennas and transmitters. The FCC requires that all RF devices be properly licensed and that they operate within specified frequency bands and power limits. The FCC also has regulations regarding the location and height of antennas. These regulations are designed to prevent interference with other communication systems and to protect public safety. The FCC also has regulations regarding the use of RF devices in sensitive areas, such as near hospitals and airports. These regulations are designed to prevent interference with medical equipment and air traffic control systems. Local building codes may have additional requirements for communication systems. These requirements can vary depending on the location, but they often address aspects such as structural integrity, wind loading, and aesthetic considerations. It's important to check with the local building department to determine the specific requirements for communication systems in the area. The National Electrical Safety Code, or NEC, is another standard that may be relevant to communication systems. The NEC provides guidelines for the safe installation and operation of electrical power and communication systems. The NEC covers aspects such as clearances from power lines, grounding and bonding requirements, and surge protection. The NEC is often used by utilities and other organizations that operate electrical power and communication systems. The Telecommunications Industry Association, or TIA, is an organization that develops standards for telecommunications equipment and systems. TIA standards cover aspects such as cabling, connectors, and performance requirements. TIA standards are often used by manufacturers and installers of telecommunications equipment. The Institute of Electrical and Electronics Engineers, or IEE, is an organization that develops standards for electrical and electronic engineering. IEE standards cover a wide range of topics, including communications systems, power systems, and computer systems. IEE standards are often used by engineers and researchers in the electrical and electronics industries. Proper documentation is essential for communication systems. All communication cables, equipment, and enclosures should be properly documented to provide a record of the installation. Documentation should include information such as cable types, routing diagrams, equipment specifications, and grounding and bonding details. Proper documentation helps to facilitate troubleshooting and maintenance of communication systems. Training is essential for personnel who install, maintain, or operate communication systems. Personnel should be trained on the proper procedures for installing, maintaining, and operating communication equipment. Training should also cover safety procedures and the proper use of personal protective equipment, or PPE. Regular training helps to ensure that personnel are competent and qualified to perform their duties safely and effectively. The NEC requires that all electrical work be performed by qualified personnel. Qualified personnel are those who have the necessary knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC. The NEC also requires that electrical work be inspected by a qualified inspector. A qualified inspector is one who has the necessary knowledge, skills, and experience to inspect electrical work and to determine whether it complies with the NEC. The NEC is updated every 3 years. It's important to stay up to date on the latest version of the NEC to ensure that electrical work is performed in accordance with the most current requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA. The NFPA also offers training courses and other resources to help people understand and comply with the NEC. The FCC is responsible for enforcing its regulations regarding RF devices. The FCC can impose fines or other penalties on those who violate its regulations. The FCC also has the authority to revoke licenses for RF devices. The FCC has a website where people can report violations of its regulations. The FCC also has a consumer information center where people can get information about RF devices and their regulations. Local building departments are responsible for enforcing their building codes. Local building departments can issue permits for construction projects and can inspect construction work to ensure that it complies with the building codes. Local building departments also have the authority to issue stop work orders if construction work is not being performed in accordance with the building codes. The electrical industry is constantly evolving. New technologies and new regulations are constantly being developed. It's important to stay up to date on the latest developments in the electrical industry to ensure that electrical work is performed safely and effectively. There are many resources available to help people stay up to date on the latest developments in the electrical industry. These resources include trade publications, industry conferences, and online forums. There are also many training courses and certification programs available to help people advance their careers in the electrical industry. The electrical industry offers a wide range of career opportunities. These opportunities include electricians, electrical engineers, electrical inspectors, and electrical contractors. The electrical industry is a vital part of the economy. Electrical workers play a critical role in ensuring that our homes, businesses, and infrastructure are powered safely and reliably. The NEC is a complex document, but it's essential for ensuring the safety of electrical installations. Understanding the NEC requires careful study and attention to detail. The NEC is not a substitute for good engineering judgment. Electrical engineers must use their knowledge and experience to design electrical installations that are safe and effective. The NEC is constantly being updated to reflect new technologies and new safety concerns. It's important to stay up to date on the latest version of the NEC to ensure that electrical installations are performed in accordance with the most current requirements. The NEC is a valuable resource for anyone who works with electricity. Whether you're an electrician, an electrical engineer, an electrical inspector, or an electrical contractor, the NEC can help you to perform your job safely and effectively. Electrical safety is everyone's responsibility. By following the NEC and other safety guidelines, we can all help to prevent electrical accidents and injuries. If you're not sure how to perform an electrical task safely, don't do it. Consult with a qualified electrician or electrical engineer. Electricity is a powerful force, but it can be used safely if it's respected and handled properly. The NEC provides a framework for ensuring electrical safety. By following the NEC, we can all help to create a safer world for ourselves and for others. The automatic meter reading transmitter installed by the power company contractor will likely need to be compliant with FCC Part 15 rules regarding unintentional radiators, as the device is likely a low-power device. The antenna installation should not cause harmful interference to other communication systems.